Hello everyone, I hope you all are doing well. Welcome back to our AWS AI Engineer Essential series. My name is Dheeraj Choudhary and today it's time to talk about the real powerhouse behind AI, that is compute. Today we are diving into Amazon EC2 with GPUs for artificial intelligence and machine learning training and inference. So let's dive in. Let's understand why GPUs are essential for machine learning training. Traditional CPUs process tasks sequentially, one after the other, meaning they can handle one operation at a time, moving through calculations step by step. And this works fine for general computing, but becomes a bottleneck for machine learning. GPUs, which stands for Graphic Processing Units, are designed to process thousands of tasks simultaneously in parallel. They have thousands of small cores compared to a CPU's few powerful cores. This parallel architecture is perfect for the type of calculations machine learning requires. Now, machine learning training involves performing millions of matrix multiplication and mathematical operations on large datasets. These operations are highly repetitive and independent of each other, making them ideal candidate for parallel processing. When training deep learning models, GPUs can be 10 to 100 times faster compared to the CPUs. What might take a week to train on a CPU could finish in hours or even minutes on a GPU. This speed difference is not just a convenience, it's often the difference between what's practically possible and what's not. Let me give you a concrete example to understand the GPU advantage. Consider you are training a ResNet 50 model, which is a popular deep learning architecture for image classification, on the ImageNet dataset containing over millions of images. On a powerful CPU, this training would take approximately 2 weeks, that is of continuous running. That's around 336 hours of compute time. So using a single GPU instance, the same training job can be completed in only one day, that is just 24 hours. And that's 14x speed up right there. The model learns the same patterns and achieves the same accuracy, but much faster. So if you use multiple GPUs in parallel, you bring that time down to 4 hours. Now we are talking about going from 2 weeks to a half day of work. This speed allows us to iterate faster and experiment with different model architectures. Now, here's the interesting part about cost efficiency. Even though GPU instances have higher hourly rates than CPU instances, they are actually cheaper overall for machine learning training. A GPU instance might cost $3 per hour versus 0.50 for a CPU instance. But if a GPU instance in 24 hours is going to have $72 total versus a CPU, it is going to have 168 when it is going to run for 1 week. So the GPU is actually more economical choice compared to CPUs. Before we talk about GPU instances specifically, let's understand what Amazon EC2 is. So EC2 stands for Elastic Compute Cloud and it provides virtual servers in the cloud called instances. So instead of buying and maintaining physical servers, you are going to rent virtual machine from AWS that are going to run in their own data centers. You can choose from hundreds of instance type optimized for different workloads. Some are CPU optimized for general computing, some have lots of memory for big data processing, and some comes with powerful GPUs for machine learning and graphics rendering. The pricing model is pay as you go, meaning you only pay for the hours your instances are going to run. If you launch an instance, use it for 3 hours and then terminate it, you will only pay for those 3 hours. There is no monthly commitment or upfront purchase cost required. The beauty of EC2 is the speed and the flexibility. You can launch a powerful GPU instance in just a few minutes, train your model, terminate it when you are done. No need to wait weeks for hardware procurement or worry about maintenance. AWS offers several GPU instance families, and choosing the right one depends on your workload and budget. So the P series instances include P3 and P4, which are designed for high performance deep learning training. P3 instance comes with NVIDIA V100 GPUs and offer the best price to performance ratio for most machine learning workloads. And these are the workhorses for serious model training. And P4 instances features the latest NVIDIA A100 GPUs, which are the fastest available but also more expensive compared to P3. So use this when you have maximum performance for very large models. So the G series instances like G4 and G5 are most cost effective options suitable for inference workloads and lighter training tasks. So G4 instances use NVIDIA T4 GPUs and are excellent for prototyping and experimentation when you're still figuring out your model structure. So this costs significantly less than P series, but still provides decent acceleration compared to the CPU EC2 instances. So AWS also offers Trinium instances powered by custom Trinium chips, which are purpose-built AI accelerators, and this can be more cost-effective for certain workloads. Though they require using AWS specialized framework, for most users starting out, P3 instances are the sweet spot, powerful enough for real training work, but not as expensive as the latest generation. Now let's talk about GPU instance pricing because managing cost is crucial for machine learning workloads. Now, on-demand pricing is the standard pay-as-you-go per hour model with no commitment required. You pay the full hourly rate, which ranges from around $3 per hour for smaller GPU instances like P3.2 X large up to 30 or more per hour for most powerful multi-GPU instances. So the advantage is complete flexibility. You launch and terminate anytime. Now comes the spot instances which offer up to 90% discount on the same hardware by using AWS spare capacity. The catch is that AWS can interrupt your instance with a 2-minute warning if they need the capacity back. For machine learning training, this is actually great because you can checkpoint your models regularly and resume if interrupted. So most training jobs run to completion without interruption. So reserved instances required a 1 to 3 years of commitment, but it provides up to 75% discount. This makes sense if you have predictable long-term training workloads, but most machine learning teams stick with on-demand or spot for flexibility. And here's a concrete example. Suppose if you are going to take a P3.2x large with one V100 GPU, it is going to cost you approximately $3 per hour on demand. And the same instance as a spot instance, if you're going to take, it is going to cost you 0.90 per hour. So if you're training a model that takes 10 hours, that's $30 for on demand versus 9 for on spot. So the savings add up quickly, especially when running multiple experiments. So now it's time for us to launch our first GPU instance and verify if it's really work. So for that, what I'm going to do is first I am going to navigate to EC2 instance, open the AWS console and search for EC2. Once I search, I select, it will open the EC2 dashboard and I'm going to click on launch instance. So I am in AWS console. I will search for EC2, opened. Once inside EC2, I am going to click on launch instance. Then once I click on launch instance, I am going to give the name as ML training GPU instance. The first and foremost thing, ML dash training dash GPU dash instance. So once we have given the name, next thing is we are going to choose the AMI. So we are going to select deep learning AMI, which is on Ubuntu, which has pre-installed with TensorFlow, PyTorch, and CUDA drivers. So for that, what I can do is I can go over here and say deep learning. So over here, what we are going to do is once we search with deep learning, you will get a list of different AMIs available. So we are going to take the AMI that is deep learning base AMI with single CUDA. Now, when we say deep learning base means what? So if you see their official documentation and scroll down to the bottom, so it says that these are the kind of, see, deep learning AMIs are pre-configured with NVIDIA CUDA, Jupyter notebooks, and all those stuffs. That's why we are using this one. So once you select that, next thing you will have to do is you have to go ahead and select the instance type. So for now, what we're going to do is we are going to select the instance type that is G4DN X large, which is the most affordable GPU. So for doing that, I will go to the instance type and filter by GPU, where I will say G4DN. So for that, I will have to click on instance type, and over here I would have to say G4. So this is, see, you can see this is the first one which comes in. So I'm going to select this. So it is also showing the pricing and everything: on demand Windows base price, on demand SUS, on demand Ubuntu base price, and on demand RHEL base price. Now you will have to create a new key pair. So I would say that I will go ahead and give the name as machine learning training key. So by using this, we are going to create the key pair and we are going to download the PEM file, which would be required for us to log in later. So I would say ML learning key, and then the PEM file is already selected. I will just click on create key pair. Once I click on create key pair, you can see the key pair has been created successfully. So once we create the key pair, the next thing is you can select your VPC, you can select your subnet, and you can have and create a new group with SSH from traffic. That should be sufficient, because right now the only thing that you will have to do is you will have to log in and check if the server is up and running, or in case if there is any issue. Then in terms of storage, so network settings, as I said, you have to make sure that your VPC has auto assign public IP enabled. And for security group, you are going to create a new security group with port 2020. And over here, you can see the port 2020 is there. You can put your specific laptop ID also if you want. That is also okay. But I am keeping it for anyone. So that, because I keep on changing my laptops, that's why. Now coming back, so after that, what we have to do is we have to set the storage. So we are going to keep our default storage as 100 GB. I will say 100. Once we do that, next thing we can go ahead and launch the instance, which will take 2 to 3 minutes to start. So I will just scroll down, nothing else you have to configure. I will just click on launch instance. Once I click on launch instance, it will take some time to install. So let me share some critical best practices that will save you money and prevent common mistakes. Always terminate your GPU instances when you are not actively using them. Unlike S3, where you pay for storage monthly, EC2 charges you hourly based on hours the instance is running. So even if you are not doing anything on it and forgetting to terminate an instance, overnight could cost you $50 to $100 depending on the instance type that you have selected and it is running. Use spot instances for all your training workloads to save 70 to 90% on cost. Since training job can be checkpoint and resumed, the risk of interruption is very minimal. So most data scientists run all these experiments on spot instances and rarely experience issues. Set up billing alarms in AWS to get email notification when your charges exceed certain threshold, and set an alarm at maybe $50 or $100 so you are notified if the costs are accumulating unexpectedly. And this has saved many people from accidentally leaving expensive instance running for days. And understand the difference between stopping and terminating instance. Stopping an instance is like shutting down your computer. It preserves the instance and any data on the root volume, and you can restart it later. You only pay for the storage while stopped, not for the compute. So terminating permanently deletes the instance. So if you are in the middle of a project and need to pause for a few days, stop the instance rather than terminating it. And that wraps today's tutorial for Amazon EC2 for AI ML workloads. If you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming tutorials. Thanks for watching, and I will see you in the next video.